Hey, so let's look at solving rational equations. So again, rational just means fractional. And solving rational equations are not that different than adding or really any of the stuff we've done with fractions so far. So we're going to start off the same exact way. Whenever you see fractions, we are always going to start off with factoring. So let's go ahead and see if we can factor. So x plus 6, 3 over x plus 6, plus 2x over x squared plus 7x plus 6 equals 1 over x plus 1. So the only part I can factor is that x squared plus 7x plus 6. So I'm just going to factor that in place. No sense in rewriting it this time. So I've factored x squared plus 7x plus 6, and I got x plus 6, x plus 1. So now I'm going to do what I did when I was adding these fractions. I'm going to go ahead and see if I can write it with the common denominator. So let's see, my first fraction has the x plus 6, but it is missing the x plus 1. So I'm going to write that in. Second fraction has the x plus 6, which is good because that's needed, and the x plus 1, which is needed. Third fraction is missing the x plus 6. So I'm going to write that in. So let's see, if I do this, I'm going to write this now as a single fraction on the left side. So I'm going to have 3, go ahead, distribute, x plus 3 plus 2x over x plus 6, x plus 1 equal, and again I'm going to distribute on the right side. It's a 1, it doesn't really change anything. X plus 6 over x plus 1, x plus 6. So now, basically I can just clear my denominators. What I'm going to do is, I see I have an equation, right? So since I have an equation, I can do anything as long as I do it both sides of the equation. So I'm going to multiply both sides of the equation by an x plus 1, x plus 6. Do it on my left side also. A little bit cramped here, sorry about that. If I do that, my denominators cancel. This is called clearing your fraction, so my denominators just cancel. And I am just left with, I might as well combine on my left side, 5x plus 2, that's a 3, 5x plus 3 equals x plus 6. Now I'm just trying to solve this. This is pretty easy. I can get my x's on one side, so 4x, my numbers on the other, equal 3. Continue solving for x. X equals 3 over 4. And that's it. I can check this. I would just sub it in. It's gonna suck basically to sub it in, so I don't really want to check it that way. What I do want to check though is that it's allowed to be this answer. So going back to my original problem, I had an x plus 6, x plus 6, x plus 1, and x plus 1. They were all in the denominator. So you remember what you can't have in a denominator? You cannot have a number over 0. So you always have to check and make sure whatever you get for your x does not make any of my denominators equal 0. So if I look at this, what would make my x plus 6 equal 0? A negative 6. So x could not equal a negative 6. What would make my x plus 1 equal 0? A negative 1. So x can't equal a negative 1. Luckily it doesn't, so this really is just my answer. Okay, let's try the second one. 4 over x minus 2 minus 3 over x plus 4 equals x over x squared plus 2x minus 8. Again, I'll factor. These tend to always factor to the other 2, so I'm going to get x plus 4, x minus 2. And then I'm going to try to write a common denominator on all of them. So my first fraction over there is going to need an x plus 4. My second fraction is going to need an x minus 2. My third fraction doesn't need anything. So I'll write my left side with just one fraction, one denominator, x plus 4, x minus 2. On the top I'll distribute. 4x plus 16. Don't forget the minus goes with that 3. So minus 3x plus 6. I'm going to change something real quick so I don't feel like having to redo everything. So let's say I make this a 7x. That will give me real numbers. I should have checked these things before I started recording. Alright, well we'll do a 7x over x squared plus 2x minus 8. Completely new problem, I decided I should have a 7. Alright, so we got 7x over x plus 4 x minus 2. Okay, so again, I'm going to clear my fractions, which basically means I'm multiplying both sides of my equation by my common denominator. All that's going to succeed in doing is canceling out my denominator. So I am left with 4x, well, I could combine, oh well, plus 16 minus 3x plus 6 equals 7x. So let's get my x's on one side. Let's combine a little bit. 4x minus 3x would be x plus 22 equals 7x. So 6x equals 22, and x equals 22 over 6, which can be simplified to 11 over 3. There we go. So, again, that's my answer. Really hard to check, so what I really want to check for is that it's allowed to be that. And if I go back to the beginning, I couldn't have x plus 4 equals 0, and I couldn't have x minus 2 equals 0. So x would not be able to be negative 4 or 2, or I wouldn't be able to sub it into the problem. Okay, let's try the last one. So I have x over x plus 3 plus 2x over x squared plus 4x plus 3 equals 6 over x plus 1. Okay, so again I'm going to factor x plus 3, x plus 1. It does generally always turn out to be the other two factors. And I'm going to try to write with a common denominator. So x plus 3, x plus 1. Therefore, on my first one, I'm going to multiply by x plus 1. Second one has both parts. The third one is going to need an x plus 3. So if I distribute, x times x plus 1 is x squared plus 1x. I'm going to write it as a single fraction, so plus 2x, because they have a common denominator now, equals 6x plus 18 over x plus 1, x plus 3. They have a common denominator, so I can multiply both sides by it, which will just clear my fractions. And I'm left with, combine as I go, x squared plus 3x equals 6x plus 18. Okay, it's a quadratic. I know it's a quadratic because of that x squared. So I'm going to get everything over to one side. So x squared minus 6x. So positive 3x minus 6x would be minus 3x. And minus 18. So minus 18 equals 0. See if it's factorable. This one is factorable. So x minus 6, x plus 3 equals 0. So x equals 6 and negative 3. Okay. So again, can't really check my answers. Just want to make sure that my answers are allowed to exist. So from the very beginning, I know that I can't have x plus 3 or x plus 1 equal to 0. So I know x can't equal a negative 3 or a negative 1. So in this case, though, my x did equal a negative 3, so that is not allowed to be a solution. It's pretty easy to see why once we have an example. If I tried to sub that in, I would get negative 3 over 0 plus negative 6 over 0 equals 6 over negative 2. Undefined plus undefined does not equal negative 3. So it's not a real answer. It doesn't give me anything real. So my only answer is x equals 6. Hopefully that made sense, and well, good luck.